Good. That was just a little taste of everything to come. So in case you don't know me, which most of you probably don't, my name is Michael Meadows. I totally got that wrong. I can't even do my own email. Hold on a second. And I got made fun of for the paragraph marks. You can make fun of me for doing Prezi here in a little bit too. About once a year I do a Prezi presentation so that I can renew that cycle of being made fun of. This is the one. So my name is Michael Meadows. I didn't even type that here. Watch. This is all about homegrown. Here I am. I'm Michael Meadows. I work with Fusion Alliance. I am an architect by trade, but a hacker at heart. And that's kind of the approach that I'm taking here when we talk about home automation. I do believe in participatory meetings or presentations. So I'm going to start by saying, you know, if you didn't go to Matt Bach's home automation talk, stand up, jump, wave your arms, do something. Okay. I want to, for those of you who did, I kind of want to differentiate myself a little bit in terms of the approach that I'm taking. So he had a pretty good analogy when it comes to home automation. Are we talking about, the iPhone version of home automation is packaged, it's nice, it looks good. The Android approach to it, which is it still works pretty well, but I can get under the hood and do some things. His talk was really focused on that, right? I don't mind spending a little time maintaining it. I want it to be mine, right? Well, that's really great, but there's a third class of people, and before I get to that, I'll kind of give you a little bit of the inception of this whole idea and how I got here. When I said, I'm going to do a home automation talk, and it's going to focus on Internet of Things, this is going to be really great, right? And I started focusing on the things that a lot of people think about, right? You know, I want to turn a light on, I want to turn it off, I want to dim it. And this is going to be really, really great, right? And I started looking at stuff. I looked at the Philips Hue, and I was like, yeah, this is really awesome. I could spend $50 for a light bulb. But I did what a lot of developers do. Okay, so how many of you here are project managers or BAs? So the project manager BA, and again, I'll spring a little bit off of Matt Bach's talk. He is a project manager BA. And towards the end of it, he kind of walked us through this really complicated scenario, which was really great, right? You know, when I go downstairs, I want to tell Alexa, hey, Alexa, turn on my projector, right? And it's going to dim the lights. It's going to go through all this really complicated stuff. And, as a developer, I'm just thinking, I don't even want to say, hey, Alexa, turn on the projector, right? So as a developer, I do what developers do, which is I start going down the road of making my life easier by doing exponentially larger amounts of work, right? So, I start going down this road of, it'd be really cool if we could do this, the hacker way, right? Which is to actually splice wires into relays and do all kinds of cool stuff. Well, and then I went off onto a tangent. So what I discovered is that there are so many really, really cool sensors. So before I even got to the automation part, I got to what I'll call home intelligence, right? Which is not security, and it's not smart homes. It's just like, what are all the cool stuff I can find out about my house, right? When people are in different rooms and what they're doing and what temperature they like it at, and how can I feed that into the internet? And if you think that I'm going to make a Terminator reference, I'm not. But there is a movie reference in here, and I'm so glad that I could get some internet because I couldn't tether to my phone. There's some things that we'll talk about. But if you fall into this camp or this camp, you'll find this talk entertaining, but it's probably not speaking directly to you because what I'm going to sell you on is this, right? And if you see this and you're like, oh man, I wish I could have done that. I don't even know what it does, right? But it just looks so cool. It's got wires sticking out of it all over the place. And it's probably, I've got 2 kids, and one of them's probably going to end up in the hospital because of this, right? But when they're 20-something, they're going to be like, yeah, this is so cool. We had wires sticking out all over the place. So if this looks cool to you, then you're probably going to want to go home and do some of the stuff I'm talking about. Otherwise, just hopefully you can find this talk entertaining. So with that, I am going to switch over to, there we go, my Prezi. And just to be clear, I'm never proud of the Prezis, but they're kind of cool. they're not really cool. But anyways, here's my Prezi, right? And so if any of you live in a weird asymmetrical black and white house, then you'll know exactly what to do. Otherwise, you got to use your imagination. But the idea is that, your house is a thing, right? And if we talk about Internet of Things, it is one of the things. And it has lots of things in it. There's lots of things that we can know. Now, I'm focused on telemetry, right? So I'll help you kind of imagine what we can do on the other end of this. But before we can even start to use all of the cool IoT stuff, we got to have lots and lots of data, right? My ultimate goal is to get to machine learning. But before I get to machine learning, I got to have lots of data to feed into it to make it do really cool things, right? And I'll show you some of these because now I have internet and I'm happy. But it starts with collecting information, right? So the proof of concept, and to be honest, I only got that and that and that. This and this. Too many late nights and too many tired mornings prevented me from getting there for this talk. But I do plan on blogging about the experience and kind of trying to form a community around it, right? The idea is we're going to buy cheap stuff and build this stuff. The execution is it ends up costing as much money as anything else, right? You end up buying soldering irons. I got a whole list to go through, right? But let me go back. But that's cool, right? So the question is, how can we get all of this stuff and ship it off to the internet? So if you read the abstract and you thought I was going to talk about Raspberry Pis, I apologize. I was going to talk about Raspberry Pis because the initial idea here was we were going to have the Arduinos sort of collect all this information and then feed it up to the Raspberry Pi and have that send it directly to the internet. But as I started going through this, I found an alternative, and I'll talk you through that. So again, I apologize. I'm really not going to mention the Pi that much beyond this, except for showing you a picture. But I'm going to get this data, and I'm going to ship it up to the cloud. I'll zoom out, because this is a Prezi. Remember, I'll get to zoom out, and you'll actually get to see the cloud. But the first thing I'm going to do is send sensor data up to the cloud. So everything I can find out about my house from my house, I'm going to send up, right? So location, basically what room is it in, date, time, how much light there is in the room, right? Because if eventually I'm going to have machine learning decide when to turn lights on and off, again, the project manager BA approach is I'm going to design this, I'm going to put all this effort into programming it, and it's going to do cool stuff. I'm too lazy for that, right? I want it to go out and ask the machine learning, when do I turn on, based on, has somebody walked into the room and never have to think about it again, right? So motion plays into that, temperature, humidity, pressure, which is atmospheric pressure, water, moisture, so put that under your sinks, put that in your basement, whether or not a door or window is open or closed, and whether or not somebody has a cell phone in your house, right, so that you can find out who's there. So who's not familiar with machine learning? Great. So the ultimate idea is that these are points of data that we're going to feed into machine learning, and we're going to build algorithms that help us decide with a certain degree of probability, do I need to turn on this light? Do I need to turn off this light? Do I need to send a notification to me that somebody's in my house and this doesn't make sense? So all of this stuff is right now just points of data that we're going to use. In addition to that, because we're in the cloud now, we can also collect other information, and this is just a small number of things that we could collect, but there's a lot of stuff that we can now incorporate into this, right? One of the things I'm planning on doing is replacing my HVAC thermostats, because I have two in my house, and I always have to run upstairs and fix one and run downstairs and fix one. And somebody's like, well, you should get a Nest. And I'm like, well, do the Nests talk to each other? And the answer is, not really. So Nests are really cool. They do machine learning, but they really only incorporate a few points of data, like time, motion, temperature. And so what I want is all the rest of this data to also impact when they turn on, how they turn on. I also want them to be able to control parts of my house, right? So if I put servos on baffles on my vents, I want the system that's controlling the temperature of my house to be able to experiment with opening them and closing them and see what works best in the house depending on who's in it, right? So that's kind of where we're going with collecting all this sensor data. Right off the bat, and I'm going to try to show you an example of this. Actually, let me see if I can start it up so that we can start to collect some data. Because I am actually feeding one device right now. I can't see it. Hold on. Data in the cloud. So if you're familiar with Microsoft Azure, this is data coming from the IoT hub. And so I've connected one device that's in my great room to the IoT hub every 30 seconds, and this should come up in a minute, or should come up in 30 seconds, right? It is shipping data off into the IoT hub. On the flip side of it, I'm going to kind of show you how we can immediately receive some benefits. So while that's coming up, actually, I work with someone who pimps Power BI like it is his stepdaughter. Sorry, I got to take it back here. I'm sorry, was that inappropriate? He'd be happy to know, anyways, that I am. Where's my mouse? Here we are. That I'm using Power BI in this example. Anybody in here work for Microsoft? Okay, good. So I can complain about the single sign-on solution, and nobody will care. Their single sign-on is the worst. Here we go. Excuse me. Okay, here it is. Okay, so what this shows you, I got to find my mouse again. All right, keyboard time. Now that didn't work either. Sorry, I feel completely incompetent. Here we go. We have motion events on the top left. This is the number of motion events that it has within a 10-minute period. Temperature, which is an average over each one of those 10-minute periods, and then humidity down on the bottom, relative humidity. So it's tracking this information in one room. That rig, or that getup, and I'll kind of show you how I put it together piece by piece, costs maybe around $30 for all of this stuff. So it's you can see it's kind of affordable to be able to get one of those into every room, as long as you don't mind it looking like, nope, hold on, this, right? So as you can see, while I was fiddling around with that, I got my data fed a few times. So this is just JSON data. It's not really that important. So if you want me to leave it up for you to look at, you can, but then we won't get through the talk. So I'm going to close it. Okay. And I'm going to close this too because that was, well, no, actually, that was cool, but we're done. And I won't reference that one again. Okay. So that's kind of what we can do with analytics. And that's stream analytics, right? That's real time. If I get a chance, if I don't get too far behind, I can show you kind of how that works in Microsoft Azure. But it looks like SQL. So you can basically write SQL queries. I can write SQL queries that can say, okay, well, is anything abnormal? If it is, send a notification to me, right? So all of these IoT pieces you can use behind the scene, but this talk is really about the things, and I want to hurry up and get to the things because that's the part that I find cool, right? So, okay. You can also create logic, regardless of which IoT solution you pick, there's the opportunity to put some sort of orchestration in there, have it make some decisions for you, whether it's based on time, complex decisions, real time, whatever it is, right? But again, the goal is to get this all into machine learning and have it make predictions, right? If it's 3 o'clock in the afternoon, and it detects motion from the garage door, it knows that's my daughter. She's coming home. She likes it a little warmer. So and also she's in. She spends time in the kitchen, the great room, her bedroom, and the bathroom, right? Until 4 o'clock happens, and then my son comes home, and then he goes off in his bedroom. It can start to collect all of this telemetry data and make some intelligent decisions about what it should do ahead of time, right? And that's the ultimate goal, but you need the data first, right? So I really focused on the data. Maybe I'll have a homegrown home automation part 2, Home Alone again. I don't. It's funny because I saw the part 2, the quickening for Matt Boxtalk, and it took me forever to get it, but Then I remember, oh, Highlander, the movie that everybody tries really hard to forget but gets reminded of at least once a decade, right? Yeah, there should have only been one, yes. Okay, so the clouds, right? I promised you that we would give you the clouds. Here they are. So all of that stuff really doesn't make a lick of difference unless you can actually have it tell something to do something, right? So that's the commands. We talked about HVAC, we talked about lights, we talked about locks, appliances, or we didn't talk about locks or appliances, but electric carving knives, tractor trailers, and 50 cal carts. So somebody's got to be excited. Do they know which movie I'm making a reference to here? Okay, so because if you didn't, it has to do with the Green Comet, and it has to do with Stephen King not being able to write screenplays, even though he writes great books. And it also has to do with the Goblin Truck. And all right. Well, you want me to reenact it? I can reenact it, or I can actually go to YouTube and get the video. You tell me what you want. Okay. As you can see, I've looked this up before. In fact, it says what? Here, I got it. Sorry. Trust me, guys, this is totally worth it. So, oops. By the way, this is Stephen King in his own movie doing the worst scene in the movie. I can't even find my mouse. There we go. Maximum Overdrive, by the way, in case I took one for the team.
Come on over here,
I actually watched the entire movie to prepare for this thing.
This machine just called me an asshole. Shut up, you goddamn stupid asshole! Can't you see we've got a situation here?
By the way, this scene had AC/DC in it. They did the entire soundtrack. The best thing that came out of this movie was the AC/DC soundtrack.
Come on, sodas. I'm buying.
Yeah. This is by far the best part of this movie.
You guys can help me pick this stuff up or what? Uh-oh.
Just step away.
Sodas. What the hell?
This is the best scene right here. You know what? I'll stop it right here. It's funny. I showed that to my kids. They were like, "I thought you couldn't kill kids on TV." So, missing video. There was another great death scene, but we'll skip right past that one too. So let's talk about the things. Because if you really want to get down to it, what we want is that mess of wires. Raspberry Pi is a great device. I was asked, and I think I never actually asked myself the question, what is the difference between a Raspberry Pi and an Arduino? So in case you don't know, I'll give you the real quick version. The Raspberry Pi is a computer. The Arduino is very, very obviously not a computer. It's called a microcontroller. And with a Raspberry Pi, if you are a programmer by trade, you can do things that make you happy. With the Arduino, it is only full of sadness. It uses a version of C++ that is like all the bad stuff, but none of the good stuff. And then when you go looking for help, especially on YouTube, it's all hardware guys, right? So they spend 27 minutes on, how to wire your capacitors and your resistors, and about 10 seconds on the code. And you can tell because when you go look at the code, it's It looks like a plate of spaghetti. So if you really want to do complicated things and you're not going to ship your data directly off to the cloud, a Pi is a great thing to put in the middle because you can use a programming language that has benefited from the evolution of our understanding on how to program in the last 30 years. If on the other hand you miss those days when you were programming in ANSI C, then you've got Arduinos to help you out here. Now, I can tell you when I started preparing for this, I bought a whole bunch of Unos because I was like, this is really, really great. But before I get to why I'm sad about having like 15 Arduino Unos, let me kind of talk about the little pieces and parts of them that are important to what we're talking about here. The first thing is what's called GPIO, which means general purpose input output, right? So these are pins that you use to communicate from either from the sensor to the Arduino itself, or from the Arduino back to whether it's a relay or something else to issue it a command. They really only care about two things: is the state high or is it low? In other words, am I getting power from that pin, or do I have no power, right? Which means that they're not really great for communicating complicated stuff. There are single wire protocols that let you do that, but in general, it's simple types of messages that you want, right? So this is the Mega, and it's got lots and lots of GPIO pins. Now, what's interesting about the Mega, you're like, okay, well then I should just get a Mega, right? It doesn't provide any more, or at least it doesn't provide that much more current than either the Nano, which you see the small one there, or the Uno, right? So yeah, it has lots of pins, but once you go beyond a certain amount, you need an external power source because there's not enough power to actually deal with all of those devices. So it's nice, but it's actually just a waste of money. The Uno is just about perfect for prototyping, and it has one whole side of GPIO pins. And the Nano is nice too because it has just about as many GPIO pins. It's just a smaller piece of hardware, right? So you also have RxTX. This is for serial communication. This you can communicate at a pretty high baud rate. It's meant for conversation, right? So two-way conversation between things. And with the Mega, you have a whole bank of them. With the Uno, you have two. You have one receive, one transmit. And interestingly enough, with the Nano, you have two sets, but they're connected to the same thing. So it's basically the same as the Uno. And then finally, you have analog. So analog is a little different than GPIO because it actually measures how much power is provided to it, and then it makes determinations based on that, right? So there are digital thermometers where you have to use a single wire protocol to have a conversation back and forth in terms of single bits. With analog, you can actually measure how much power you're getting back from the thermometer and do all kinds of really, really crazy math to get to a temperature. And the Mega has a whole bunch of them. The Uno has a few, and the Nano has a very few. So, and I'll get into the problems with power management in a little bit, but this seemed really great until I tried to connect it to the internet. And what I found out is that the Arduinos are like my grandparents, right? They were invented before the internet. So when it comes to being able to actually do the IoT stuff, they're really awful, right? So there's actually a chipset out there called ESP8266, and that's really special because in that little tiny package, and this guy you can buy for like $2, $3, I think $3. Well, he's saying $4, but I think I bought him on Amazon for $3. They connect to the internet, right? And what's really interesting, let me zoom in here, is that this guy has 2 GPIO pins. So if you only need 2, you can actually flash this guy so that it acts like an Arduino, right? So if I go back, you may not even need these guys, right? Especially if we're talking about hooking just a couple sensors up to them. So it's got a couple GPIO pins, no analog, but it does have TX and RX, right? Here's the problem. This guy runs on 3.3 volts. The Arduino and most sensors run on 5 volts. I'll get into that, but that hurt my feelings, right? Because after I bought like 27 Unos, I found this guy, and I bought like 15 of these. and now I have, I don't know, I'm even too tired to do the math, 27 plus 15 things that I don't use because I discovered this. So the one that I just showed you, that was the ESP1. That was the first generation of this ESP8266. This is the ESP12, and this is like the Cadillac, right? Because if you look at this guy, it's got the same chipset. It actually communicates to Wi-Fi, but it's got 9 GPIO pins. It's got TXRX, just like the Nano. It's got it in 2 spots, but it's the same one. It even has an analog pin, right? So in almost every case, this is all you need. What makes it even better is that when you feed the power, it can convert that power, whether it's 4 volts to 12 volts, it will step it down to 3.3 volts so that it's safe. Except the GPIO pins are still 3.3. So you can't you can power your sensors, but when you receive the data back, you still have to step it down to 3.3 or you burn your board out, right? There's no happy universal solution, I can tell you that right now. But that's why if you think having lots and lots of wires sticking out of boards is fun, you'll really find this fun. So, okay. So let's talk about power, because power is really the bane of my existence, right? Why? When the guys came along and invented this 8266, I understand that they wanted it to be low power because, this is an IoT thing, right? We don't want it to consume more power than it needs, except for the problem is everything uses 5 volts, right? So this drives me nuts. But so 5 to 12 volts, Arduino, most sensors, and USB. 3.3 volts, again, the ESP8266, and very, very few sensors. I'll repeat that. Very few sensors. And it gets complicated. I'll kind of show you the workarounds. It makes you feel good once you get them all put together, but it just means you have to buy more parts. And then nothing does it definitively. Arduino outputs 3.3 volts, but the amperage is so low that you actually can't use it for anything. And then the ESP12, as I mentioned, will step down your voltage to 3.3, except that your sensors still have a problem if they run on 5 volts. There's actually one thing that I'm going to show you where it magically works, and that's because the sensor itself is stupid. So we'll get to that. Okay, so logic level converter. If you don't know what a logic level converter is, do nothing. Okay, good. So what a logic level converter does is it has a high side right here and a low side. And you feed those both from separate power sources. And then what you do is your pins feed into in this case, the A pins and the B pins. And if an A pin receives a signal, it activates the B side to send that signal at the other voltage. They're actually not connected, but it basically sends the power from either the high or low side depending on which side, depending on the opposite side. That's why it's called bidirectional. $7 on Amazon, right? Oh, and by the way, if you guys haven't signed up for smile.amazon.com, just go ahead and do that. It's exactly the same as Amazon. They just give some money to charities if you buy it that way. So, I mean, this is fine, but I really hate having to have all my sensors go from one thing to another thing. It just adds to the complexity of the things that you're building, right? But you got to do it, unfortunately, if you want to connect to the internet. Oh, with the exception, if you don't mind spending between 4 and 5 times as much for a shield to put on top of your Arduino, go ahead and do that. Then you won't have to deal with this problem because that runs just fine. But again, that's kind of not the hacker solution. That's the I'm going to throw money at the problem solution. The hacker solution is I'm just going to have lots and lots of wires sticking out of things, right? And this guy guarantees to double the number of wires that you have from every sensor. So it's a perfect solution in that case. Okay, so problem number 2. If we're talking about building IoT devices, We could take a USB. We could take a. They call them wall warts, I think, because they're ugly. Let me step back. I've got some time. What time am I supposed to be done? Okay, good. We got plenty of opportunities to get sidetracked. So, okay, who here is a fan of Tesla and is so glad that Tesla won the AC versus DC battle? Yeah. Here's what I can say. Tesla was both brilliant and he was wrong. So AC won because AC, you can transmit AC over very, very long distances, whereas with DC you couldn't, right? But think about your house. How many things in your house actually run on AC? I can think of incandescent light bulbs, which we're phasing out. I can think of a vacuum cleaner and a corded drill. Everything else, you got to plug a wall wart into the wall and then plug that into your thing. I mean, your TV, you don't see it, but it's there. It converts it from AC to DC. Your Xbox, your cell phone charger, everything runs on DC, including your IoT devices. If you try to plug it directly into AC, you will end up with a cloud of smoke. So, as you can see, $10 more to convert your AC power from your wall, because again, this is the hacker solution, right? What I'm going to do is I'm going to splice directly from my wall into this thing. I'm sorry, I was just about to say a curse word. I want shit hanging out of my walls, right? Now, here's another problem with this. So this is great. I can buy this. I can convert my AC power to DC so that I can power my IoT devices. That's a toilet, right? Look at that thing, right? I mean, there are other ways to convert AC power to DC, but the safest way is to get one of these things. It's got capacitors, transformers. I don't even know what that is. That may be another transformer, diodes, whatever. It's like 4 times bigger than the actual thing that I care about, right? So, I mean, whatever. We got to deal with it, and there's not much until Edison can come back and convince the power companies to switch to DC at your house instead of stepping it down from 30,000 to 110. We're stuck with AC. Okay, then we got our FTDI and TTL cables. So, what I showed you the ESP12, which I think is like the best thing since the ESP1. It has no USB, so if I want to actually program that thing, I gotta plug some of these wires into it and kind of do some crazy stuff. You can actually Adafruit, who makes that ESP12, actually makes another product called the Feather, which has micro USB built into it. I did the math. I think you can go to Micro Center and buy the ESP12 for $10. You can buy the Feather for $20, right? So I could actually buy a TTL cable with every single ESP12 and save myself $3, right? It's your choice. Again, convenience versus hackership. Now, I admit I tried this because I discovered my problem late one night, and I didn't want to wait 2 days to get this stuff from Amazon, and I didn't want to wait till the next morning to drive down to Micro Center to pick up this cable. I was like, okay, well, you know what I'm going to do? I'm just going to rip apart one of my USB charger cables and stick these little ends on it and see what happens. Well, it doesn't work. This ugly little piece right here converts it to a parallel or serial. Thank you, serial signal. Now, if you're wondering why this FTDI cable is so much more, it's because network people buy that, right? So, like, if you're associated with Cisco, then you're willing to pay $20 for something that could cost $7. The only difference here is that this is really, really easy to plug into. The pins line up exactly with the pins on the ESP12. So if you're going to do this a lot and it's worth an extra $10 or $11 to you, then go ahead and buy the FTDI cable. Otherwise, what you're probably going to have to do is scratch your head every single time you plug this into your ESP12, trying to remember, okay, well, which one was TX and which one was RX. But what I do is I printed out a picture and I have it hung up on my wall so I can remember. What's that? Yeah, I could. Okay, so remember when I was talking about the... did I put something funny there? Or? Okay. When I was talking about the stupid sensor, this is the stupid sensor. PIR stands for passive infrared sensor. It's also called a motion sensor. You can buy these things for less than $1 each, right? So I'm willing to deal with the stupidness, especially since it works in my favor. So when I had this running on my Pi, or not on my Pi, but on my Arduino, everything worked really, really great because I was feeding it 5 volts and I was getting back about 3.5 volts. And the thing about the Arduino is as long as it's over 3 volts, it thinks that it's a high signal, right? So it was working perfectly. And I switched, when I finally discovered how to make the ESP12 work, I plugged it into my ESP and I was getting all kinds of crazy results, right? And I couldn't figure it out, and I went all over the place, and they're like, oh, put aluminum foil over your antenna and all this stuff, right? Well, as it turns out, I finally hooked a multimeter up to it. I was losing about 30% of my power between what I fed into this thing and what I was getting back. So when I had it plugged into 3.3 volts because I didn't want to burn out my ESP12, I was getting back maybe 2.5, something like that, and it didn't know what to do with it, right? What's beautiful about this is if I feed it 5 volts, I get back just the right voltage for that ESP12. So this is the one where I don't need that logic buffer. So this crappy, you can also go to the internet and it'll show you how to like desolder things from this to get your voltage back. I actually don't know what happens if you do that. I'm sure it won't catch your house on fire. So this is your PIR. This is a really important and very cheap piece of your IoT telemetry solution. Temperature and humidity. Okay, so there are a lot of different sensors that measure temperature and humidity. I mentioned that there are analog ones. I actually don't like the analog ones because they're very, very sensitive to the amount of voltage coming in. So unless you are confident that you can regulate that voltage and then feed that voltage back into the crazy math that you have to do, and it is absolutely crazy, then go with these guys. This is a single wire, or actually no, I see 2 wires. But anyways, this uses your GPIO. I wouldn't want to have to implement the code that communicates to it, but luckily Adafruit has already built those libraries, so you can use those. The only difference really between the 11 and the 22 is that the 22 gives you much better accuracy at the expense of only being able to ask it about half the time. But honestly, I mean, if you want to know what the temperature is any less than 2 seconds apart, you're probably micromanaging. So these guys are great. The telemetry data that I showed you coming back is using these. It is temperature and humidity, and it's they say it's accurate, but it really is only accurate on whole degrees of Celsius. But it's still good enough for me. I'm happy. Okay, so relays. So I'm kind of done with the telemetry part, and so the question is, okay, well, I want to hack more. What do I do, right? You could spend, what was it, $45 for a special light switch that you can use Z-Wave to tell turn on and off. You could do that, or you could duct tape one of these to your walls, and pull the wires out from your wall. You probably actually won't be able to pull it out, so you have to get one of those little cap things and get some 12 gauge wire to stick into these things. If you've got kids, just I don't know, put scary pictures around it so they don't touch them. But this is way cooler, right? So there's a difference. These guys are cheaper. Relays will run you anywhere between $3 and depending on how many you want, right? $40, $50. The switching relays are cheap. They're very reliable. They're also noisy. They make that click click sound every time they switch. They're interesting because they have the normally on, normally off, and ground. So you can kind of choose which one you hook up your hot wire to, the normally on or normally off, depending on how you want it to behave. The solid states are even better because they're quiet. I think they're a little bit less reliable, but who cares? And they're really, really fast, right? So if you're like, well, I want to dim that AC light because I still care about AC, these guys can switch on and off really, really fast. So you can actually you can actually dim it by catching that sine wave in your AC at just the right point and cutting off the power and then turning it back on. I think that's when I kind of took the left turn to stop trying to make fancy things happen with light. Because I could have come in here and I actually have this stuff, right? I mean, some of my coworkers and I built a fan that we can switch on and off, and then I hooked it up to the temperature sensor to say, hey, look, if it gets too hot, turn on. But ultimately that's like a 10-minute presentation, and I had to fill another 40, so I took a different direction, right? So you can actually dim lights using this guy, not this guy, because it's too slow. All right, so there's other stuff. So if you think it's as easy as doing everything I just told you, just keep in mind if you're married. Okay, how many of you are not married? Okay, you guys won't have a problem. For the rest of you, when the Amazon box comes like every other day because you're like, oh man, I need another thing. Your spouse starts giving you funny looks, right? Like, when does this end, right? This is kind of like if you're in consulting, it's kind of like an RFP project, right? The change requests just keep coming in. So this is a lot of stuff, right? The things I didn't show you, breadboards. So breadboards are great for prototyping because you take your little wire and you stick it into the breadboard, and then you take another wire and you stick it into a different part of the breadboard, and the signal is carried through. It also looks really junky when it's done, but that's when you can start working on prototyping boards where, if you think soldering is fun, then there's a lot of fun to be had there. But that's really kind of useful because then I can start to go in maybe to a printed circuit board program and kind of design the circuit board and then send it to some company that prints it. Or if you really feel, and I haven't gone this far, but if you really are feeling adventurous, you can actually go buy some stuff like, you can just take a copper board and dip it in this stuff that I'm sure is not healthy. And you can make your own little printed circuit boards. Or not, I guess they're not printed, but you can make your circuit boards. Etched circuit boards, thank you. They actually have an inkjet version too, but so there's crazy stuff you can do. Resistors, diodes, capacitors, you need just bunches and bunches of those. Optocouplers are kind of interesting because what an optocoupler does is it separates two sides of a board in terms of power. So if I have higher voltage on one side and lower voltage on another and I need to hand off a signal, an optocoupler can do that for me. LEDs, because they're fun, and specifically if you haven't ever worked with addressable LEDs, it's just really cool to make them like make rainbow colors. I'm sure there's other stuff you can do with them, but for a $60 investment, I've made rainbow colors. Wire, it's never bad to have lots of wire, but specifically for doing this stuff, you should have 22 gauge stranded wire, not solid core wire, because to skip ahead, all of these DuPont connectors, you saw the little black housings with the male one having like the little metal sticking out and the females, and you can kind of stick those into your header pins. Eventually, you're going to get really, really tired of running out of jumper wires, and you're just going to want to make your own. So that's that part, right? Heat shrink, because once you get good at soldering, you're going to solder everything together, and you don't want those wires touching each other. Tweezers, because you're going to drop small things, and if you have big fingers like me, that's not a good thing. Magnetic screwdrivers, and I'm sure all of us have at least one of these. A multimeter, because that's how you debug these. Standoff spacers are, if you want to start actually making things look nice, they're just nylon spacers. Jumper wires, header pins, all that. Okay, so and then the last thing here is soldering, right? And this could be another hour-long talk. There's so much that you can get wrong with soldering. I can tell you I've gotten every single one of those things wrong. I started learning soldering last year. And it was only many burnt fingers and probably destroyed lungs later that I discovered, this is something that takes a little time, right? If you're going to do it, don't make the same mistake that I made and buy the cheapest one you can get, or like, hey, if the cheapest one's 20, I'll spend 30, right? The minimum cost for a soldering iron that won't fill you with woe is $100. You will you will just not get it if you start with the cheap one. Maybe if you're really good to start off with and you go with the cheap one, that's fine. But this is the one case where I think you just can't start cheap, right? So the only two brands that I think anybody trusts is Weller and Hacko. Hacko is kind of the generic Weller, so if you're looking to save a couple dollars, I think that there's no loss in quality there. Again, because we're working with circuit boards, you want 0.6 millimeter solder, and don't be a hippie. Buy the lead tin ones. Yes, it's lead, and yes, you're going to stick your head over it, and yes, you're going to take deep breaths, but it's totally worth it. Solder sucker, and I know this sounds really kind of inappropriate, but you're going to spend more time when you start learning solder unsoldering than you're going to spend soldering. So it's just like a little, you kind of push the thing down, and then when you push the button, it like creates suction and sucks the hot solder out. Brass coil tip cleaner, this is something that people don't tell you often, but usually when you see people soldering, they use a sponge. Don't use a sponge, use a brass tip cleaner. It's just kind of like, it looks like Brillo, but don't use Brillo because it will catch on fire. Yes, I learned that the hard way. Sal ammoniac tip cleaner, which is just kind of like a block of salt, but once your tip gets really, really gross, you kind of have to clean it off. Flux, and so I'll tell you, I was actually working with much higher amperage stuff for a while, building racing quadcopters. So I was working with 12 and 16 gauge wire, and there's something that you do with stranded wire called tinning it, right? Which is you want to put solder on it before you try to solder it to something, and I couldn't get them tinned. And it's because as soon as they get hot, they oxidize, and as soon as they oxidize, they don't conduct heat anymore, right? And I spent weeks just thinking I'm so terrible at soldering, right? Until somebody's like, no, you just need to dip it in flux and you're fine, right? And it's true. Like the moment I dipped it, the moment I got that rosin paste and I dipped the tip in there, it was like I was suddenly a soldering genius. So if you're really great, and I'm starting to get to that point, you can actually solder in a lot of cases without having to slather everything in flux. But when you're just starting, don't be afraid to over-apply the flux. And then helping hand is not your child or your wife or your husband. Yeah, because we have a few women here. It is actually just little alligator clips attached to a base. And if you really go all out, then it's got a magnifying glass too. But I never actually find use for the magnifying glass because it's kind of weird trying to control that. But you definitely need a helping hand or some ghetto version of it. Okay, well, and then I was going to close with another video, but which is okay. It was just going to be the Who Made Who video. So we've got time. I have more content. I can show you the cloud stuff, or I can answer questions. So, what's that? Unfortunately, I don't have it. I've got 3 or 4 different things that. Well, I'll tell you what. If I go back to this, the last piece here, anti-architect. If you want to, I can go home and tweet out the pictures of the things that the things I've done. They're a little cleaner than the picture I showed because I did spend a little time iterating over it. So I'll go home and take pictures and I'll tweet those out if you want to do that. No pressure to follow me, but okay, questions. Go ahead. Okay, yeah. There's no IoT there, but so my 7-year-old son, when he was 6, and I kind of decided to go down the road of building these things. So when I talk about the Arduinos, they're called microcontrollers. This revolution of microcontrollers has really made things like racing drones really, really affordable, right? So for about $35 to $50, depending on which microcontroller you get, it comes with an accelerometer, and it comes with pretty sophisticated stuff that allows it to control the motors independently. The startup cost on one is about $1,200 because you have to buy a pretty nice transmitter, and you have to buy the goggles to look at it. But You basically buy a carbon fiber frame, you put motors on it, you buy these things called electronic speed controllers, which receive a digital signal from that microcontroller that tells it, spin this thing faster or slower, and you have to buy very, very dangerous lithium polymer high discharge batteries. So basically, anywhere between 1,500 and 4,000 milliamps discharging in about a 5-minute period of time, which is why you need that really thick wire for it, because if not, it gets really, really hot. But there are a few events. If you really want to see, I think the biggest one we have is hosted by a company based out of Lewis Center up on the north side of town, and they go up to Willard, Ohio on an annual basis. They're called Ready Made RC, and they rent out the airstrip and they do racing for 2 days. So it's a blast. It is not a cheap hobby. Yeah.
Like you, I've been doing a lot with Arduino, and I've been working my way through electronic circuits for an evil genius. And I was curious if you had any book recommendations.
No. Okay. So the question was book recommendations, and I hadn't heard of that. What do you call electronic circuits for an evil genius?
Circuits for an evil genius. There's a bunch of evil genius series, but electronic circuits for an evil genius. It's pretty good.
No, I everything I know I learned from YouTube. So I am very interested in reading some books targeted towards hackers who want to do this, especially people with a programming background. But I can tell you, because of work, I lost 2 weeks of preparation for this. So it was just basically, as much as I could suck into this porous brain in a short period of time. Yeah.
You want to read Forrest Mims' engineering books?
Okay.
Shaq used to sell them, and it's all like basic electronics theory, but it's really simplified.
Okay.
Tons of circuits.
He said his name is Forrest Mim?
Forrest Mims.
Mim, okay. Yeah, so the recommendation was Forrest Mim's engineering books. It is funny because you can tell the engineers from the programmers when you go out and look at these pages. Most of them are engineers, but the very few programmers that you find actually try the really hardest to make the code not suck at the expense of really crazy solutions in the on the circuit side. Yeah.
I had one follow-up question.
Sure.
I tried working with home automation myself, and I made the mistake of asking questions on the electronic engineering stack exchange. Have you done that?
Okay, so the question was asking Stack Exchange for help. It's funny because I gave up on Stack Exchange a long time ago. I actually have a pretty high reputation on the original Stack Exchange site, which was Stack Overflow, but it really just became gamification pretty quickly. So the problem is that the answers that you get a lot of times are really just around getting plus ones or plus, the extra 10 points. So no, I haven't, and it's funny. I found very little useful information in those forums as I was going through this either. So.
You should go post one of your pictures of hacking into the AC on the electrical engineering site.
Yeah.
See what they say. Give somebody a connection.
Yeah. So I'll hold off on that in terms of posting the pictures of hacking into the AC. But when I get ready to do it, maybe I will. I think the thing that I care a lot more about is the machine learning part. I just find that to be really cool.
So if you still have landline in your house, it's 24 volts DC.
Yeah.
Yeah.
Landline. I didn't know that. So the red wire coming out of the landline is 24 volts. Okay.
There's actually appliances that you can buy that run off of it.
Yeah. Well, that makes sense. It's the one DC. Your phone line is the one DC source coming into your house. So you can basically leech off of that, right? Because even if you're not using the phone, you're still getting the power still coming through, right?
It has to.
Yeah.
9/11 support.
Okay. So free power, right?
Whether or not they're going to catch you is another matter. But.
Yeah, and I could step-down converters are not that expensive. So that's interesting. When I built my house, I should have been like, I need a phone outlet in every room. Like, really? Okay. So anything else? We do have 5 minutes. If you want, I can show you the little bit of stream analytics. Oh, no, go ahead, Patrick. Sorry. Yeah, the question is how can we bring home automation to the toilet? The answer is you can do like I did before I started doing all this thing and buy a $500 toilet seat with a reservoir, and it does machine learning too because it knows, like I never sit on a cold seat, right? Or I honestly don't know how close I want my hacker stuff to my butt. So the possibility is there. That's one place where I have the budgetary authority to spend because I will say, a lot of people are like, that's crazy, right? Why would you spend $500 on a toilet seat? But once you have one, you want them in every room. And this is the one place where spousal approval will happen, right? Because it is so nice in the middle of winter when you wake up for that quick pee and you're somebody's wife. Because like if you're a dude, it's like, I'm not even going to turn on the light. If I miss, I'll clean it up tomorrow. But if you're my wife, you have to sit down, and that's where all the trouble starts. And that's where the $500 toilet seat helps. The first one I bought was from a company called Clean Butt. They've since changed their name to BioBidet, but it is really, really great, and I would recommend it to everyone. I haven't quite figured out how to automate it, but the opportunities are there. Okay. Well, I thank you for sticking through with me, and hopefully we can get back together next year, and you guys will tell me all the cool stuff you've done, and I think it'd be really cool if we would go back to talking about the Apple versus the Android, to have a third community that is not. It's not really based on products, but it's based on ideas. To open source these designs and eventually to be able to commoditize them in such a way that we can, a lot like we're doing with software, but just in the automation space, right? A lot of stuff is really driven around products and product companies. And kind of as somebody who is a hacker at heart, I want an alternative, right? Which is why I started down this road. So thank you, everybody, for hanging out.